Assalamu alaikum. Today we are going to start by a new chapter which is Alkanes. The objectives to be covered in this chapter are: define hydrocarbons, distinguish between saturated hydrocarbons and unsaturated hydrocarbons, recognize the term first, alkanes with straight chain, distinguish between the different types of representation of an alkane, recognize branched chain alkanes, and finally identify alkali groups. Hydrocarbons. This name can be divided into two parts. The first part is hydro, which means hydrogen, and the second part, which is carbons, which means carbon. So the definition of hydrocarbons. Hydrocarbons are organic compounds made up only of carbon and hydrogen elements. They are represented by the general formula CXHY. Which among the following organic compounds are hydrocarbons? Pause the video and try to solve this question. We said that hydrocarbons are organic compounds which are made up of carbon and hydrogen only as this molecule. So this is a hydrocarbon. For this molecule we have chlorine without hydrogen, so it's not a hydrocarbon. For this one, this is a hydrocarbon since we have carbon and hydrogen only. The same for this one and the last one. All the remaining organic compounds are not hydrocarbons since we have oxygen beside the hydrogen and carbon. Hydrocarbons can be classified into two groups. The first group is saturated hydrocarbons and the second one is unsaturated hydrocarbons. What is the difference between these two groups? First of all, saturated hydrocarbons are hydrocarbons where all the bonds between carbon atoms are single covalent bonds. So when all the bonds between carbon atoms are single covalent bond, we are talking here about saturated. But when we talk about unsaturated hydrocarbons, and we have at least one double covalent bond or triple covalent bond. In this case, the hydrocarbon is said to be unsaturated. Which of the following hydrocarbons are unsaturated? We have to look at the bonds between the carbon atoms. Here we have triple covalent bonds, so it's not a saturated hydrocarbons. For this compound, all the bonds between carbon atoms are single covalent bonds, so this compound is saturated hydrocarbons. This one is unsaturated hydrocarbons since we have a double covalent bond. For the fourth organic compound, this is a saturated hydrocarbons since all the bonds between carbons are a single covalent bond, and the same for the last organic compound. Saturated hydrocarbons can be classified into alkanes with open chain and cycloalkanes, which are alkane with closed chains or cyclic alkane. So also alkanes with open chain can be classified into alkane with a straight chain and alkane with branched chain. But the general formula of these two groups is CnH2n plus 2, while the general formula for cycloalkanes is CnH2n. Now, the first 10 alkanes with a straight chain of a general formula CnH2n plus 2 are the following. For the first one, we replace N by 1. When replacing N in the general formula by 1, we get the methane with the general formula or the molecular formula CH4. For the second one, we replace the number of carbon N by 2. In this case, we get ethane of molecular formula C2H6. If you look at the names of these alkanes, you can notice that all of these names end by ane. So methane for the first alkane, ethane, propane, butane, pentane, and etc. and represent the number of carbon atoms in the molecule. The representation of hydrocarbons. A hydrocarbon can be represented by its molecular formula or by its structural formula or by its condensed structural formula. What is the difference between these representations? In the molecular formula, Each atom that constitutes the hydrocarbon is represented followed by an index that shows the number of this atom in the molecule. Example for CH4. In CH4, you can notice that in this formula, atoms that constitute the molecule and the index that show the number of each of these atoms in the molecule. The same for C2H4, we have the atoms that constitute the molecule and the number of each atom in this molecule. For the structural formula, all atoms that constitute the hydrocarbon and all the bonds between them are represented as this example. Here all the bonds are represented and all the atoms that constitute the molecule. While in condensed structural formula, we represent each carbon atom with its hydrogen are written as a group. So if you look at this condensed structural formula, here we have 2 carbon atoms. Each carbon is surrounded by 3 hydrogen atoms. So, and the carbon and the hydrogen that surround it are represented as one group. In the condensed structural formula, we can represent the bond between 2 carbon atoms or not. So these 2 formula are called condensed structural formula. Now in this application we have to indicate the type of representation in each case. So for the first one, all the bonds between atoms are represented and all the atoms in the molecule are represented, so it's structural formula. In the second one, only the atoms that constitute the molecule are represented and the index that show the number of each atom in the molecule, so it's a molecular formula. Here in the last 2 representation, you can see that each carbon with its hydrogen that surround it are represented as a group, so it's a condensed structural formula. But in this one, the bonds are not represented. In the last one, the bonds between carbon atom are represented, so they represent condensed structural formula. The same for the last one. Now let's solve together exercise 8, page 240. In this exercise we ask us to correct the following structural formulas with respect to the missing hydrogen atoms, knowing that carbon is a tetravalent atom. What do I mean tetravalent? If you remember that carbon has a valence which is equal to 4. So to verify its octet rule, it has to make 4 single covalent bond or to share 4 pairs of electrons. For the first carbon here, this carbon makes 3 single covalent bonds with 3 hydrogen atoms and 1 single covalent bond with carbon atom, so it verifies its octet. For this one, it makes 2 single covalent bond with 2 carbon and 3 covalent bond with 3 hydrogens, so it makes 5 single covalent bonds. So we have to take 1 hydrogen for this carbon to verify its octet rule. For this one, 1, 2, 3, it needs 1 hydrogen. For this one we have 2 and 2, so it verifies its octet. For this one we have 4 single covalent bonds. For this one we have 3 and 1, 4, 3 and 1, 4. For the last one we have 1 and 2, 3, so it needs 1 hydrogen carbon. For this one, this carbon makes 2 single covalent bond, one with hydrogen and the other with chlorine, and 1 single covalent bond with carbon, so it needs 1 hydrogen. For this one we have 2 single covalent bonds with hydrogen and 2 single covalent bond with each carbon, so it verifies its octet. For this one also it verifies its octet. For this one we have 1, 2, 3 and 4, so the formula is correct now. For this one, for the first carbon we have 3 and 1, 4. For this one we have 1, 2, 3, 4, 5, so we have to take 1 hydrogen. For the third carbon we have here 2 hydrogen and 2 single covalent bonds with carbon, so it verifies its octet. We have 1, 2, 3, it needs another hydrogen. This one is correct, 1, 2, 3, so it needs also 1 hydrogen. Now branched chain alkanes. What is the difference between straight chain alkanes and the branched chain alkanes? Both have the same general formula, but the difference is in the structural formula. The structural formula of a branched chain alkane is made up of two parts, the main chain and one or more branches. What is the main chain? The main chain is the longest straight chain in the formula. That means that the one which contains the greatest number of carbon atoms, while the branches or alkali group an alkali group is obtained when one hydrogen atom is dropped from an alkane. It has a general formula CnH2n plus 1 because we dropped one hydrogen atom. These groups represent the branches which are attached to the main chain by single covalent bonds. The name of an alkyl group is the same as the corresponding alkanes by replacing the ending "ane" by L. Like this. Here, to determine the main chain, we said that the main chain is the chain that contains the greatest number of carbon. We have to count the carbon atoms which are placed successively. Like this. 1, 2, 3, 4, 5, 6. 1, 2, 3. 1, 2, 3. 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. So the longest chain is the chain that contains 6 atoms. You can choose one of these longest chain. Now all the other group represents the ramification or alkali group. What are the alkali groups? We said that alkali groups have the general formula which is CnH2n plus 1. So to get the different alkali groups, we have to replace N by different number. The first alkali group is obtained when replacing N by 1 and we get the methyl. We said that the name of the alkali group is get from the corresponding alkane by replacing the suffix ane by L, so it's methyl, and the molecular formula or the formula of this alkali group is Ch13 by replacing N by 1. The same for ethyl by replacing N by 2. For propyl we replace N by 3, but for propyl we have two propyl. Propyl 1-propyl or isopropyl, which is called also 2-propyl. These two alkali groups have the same number of carbon, but what is the difference between them? The difference is the atom which is attached to the main chain. If the atom at the extremity of the chain is the one that is attached to the main chain, the alkyl group is called 1-propyl. If the central atom is attached to the main chain, the alkyl group is called isopropyl or 2-propyl. So it depends to the carbon which is attached to the main chain. Now, as summary, we studied in this lesson that hydrocarbons are organic compounds made up of carbon and hydrogen only, and that in saturated hydrocarbons all the bonds between carbon atoms are single covalent bonds. The general formula of a straight chain and a branched chain alkane is CnH2n plus 2 for both. A branched chain alkane is made up of two parts, the main chain and the branches or alkyl group, and the general formula of alkyl groups is CnH2n plus 1. Of course, you have to memorize the name of the first 10 alkanes and the name of the alkyl group. And thanks for watching, and for the next time.